Hello students, welcome to the session. Today's topic for the session is properties of a tangent. So let's start the session. So first of all, we should know what is your tangent. A tangent to a circle means a line touching the circle at a single point. A line touching the circle at a single point. So it should touch, it should not intersect. Okay, this is your tangent. This will be your tangent, and this will not be considered as your tangent. Okay, this is not considered as a tangent as it is not touching. Here the word touching is important. It should touch the circle, and here it is intersecting, it is not touching, so there is a difference. Okay, so this is not allowed, so this is your tangent. Okay, and also at a single time, at a one point, if from only one tangent is possible from a single point. Okay, so this is your circle, and the point of contact is always one if there is one tangent. Okay, so through one point we can draw only one tangent. So if there is a point, we can draw two tangent to a circle like this is one tangent and this is another tangent. Okay, so from this external point we can draw two tangents. Okay, so this is your point of contact P, this is your A, this is your B, and again if your point of contact is B, we can draw the two tangents. And most important thing is that the length of these two tangents are equal. So the length of these two tangents will be equal. So exactly two tangents will be drawn if the point is outside the circle. If the point lies on the boundary of the circle, we can draw only one tangent. Here one tangent is possible, and here two tangents are possible. Okay, now some properties, we will write the properties of this. The tangent always touches the circle at a single point. Yes, it is true. The tangent always touches the circle, always touches the circle at a single point, always touches the circle at a single point. Yes, it is true. So we have seen also that if in this case there is a single point of contact, and also in this case there is also a single point of contact. So a tangent always touches the circle at a single point. Okay, now the next property, it is perpendicular to the radius of the circle at the point of tangency. That means it is perpendicular to the radius. It is perpendicular to the radius of the circle. The tangent is perpendicular to the radius of the circle at where? At the point of contact or tendency. The point of contact or tangency means, see, if you have a circle, this is your tangent, this is your O center, and if we draw a perpendicular like this, it will be your perpendicular to the point of contact. Let us say it is your P and it is your AB. Got it? It is your P and it is your AB. Fine. So in this case, it is saying that it is perpendicular to the radius of the circle. The radius of the circle is, this is your radius. Radius of the circle is always perpendicular. Similarly, in this case, if my tangent is like this, this is your point of contact, here it is your center, and here it is your radius. So the radius is always perpendicular. So radius is always the perpendicular, okay, to the point of contact. So let us say it is P, it is A, it is B. Okay. So, and the third point is that now we are clear that your radius is always perpendicular to the point of contact of that, and that is your tangent. The next point is it never intersects the circle at 2 points. It never intersects the circle at 2 points. It never intersects the circle at 2 points. That means it is not allowed like this. Okay, it is not allowed like this. This is not permissible. It is always just like touching the circle at a single point, touching the circle. Okay, so touching is allowed, but intersecting the circle is not allowed. And the length, the last part is your the length of the tangents. The length of tangents from an external point to a circle are equal. Okay, the length of tangents from an external point to a circle are equal always. So if my external point is this, if I draw two tangents like this and this, so the length of this PA and PB. So here the point of contact is A, here the point of contact is B. Now here your PA is equal to PB on this. That means that tangent drawn from the external point, that these two tangents they are equal in length. Okay. So now, and also if we draw here, this is your center, and if we draw a perpendicular to this from the this is your radius, and the radius joining the point of contact and this, they are always perpendicular. They are always perpendicular. So based on this, let us do one numerical. A tangent, PQ at a point capital P of a circle of radius 5 centimeter meets a line through the center O at a point P at a point Q, so that OQ is equal to 13 centimeter. Find the length of PQ. Now see here, tangent PQ at a point P of a circle. Okay, so your circle, you have a circle PQ, the tangent PQ at a point P of a circle. Okay, that means tangent is your PQ at a point P of a circle, and Q is somewhat here. And now radius is your 5 centimeter. Radius means joining center to the point of contact, and this is always your perpendicular, and the radius given is 5. Meets a line through the center O at a point Q, so that OQ. Okay, line from a center O to this, and the length of this is OQ, and OQ is 13 centimeter. Find the length of PQ. Now, since it is your 90-degree, and we know that this is your right angle triangle, and what we know, this is your right angle triangle. OPQ is your right angle triangle. Triangle OPQ, right angled triangle. Got it? So this is your right angle triangle. And we know in right angle triangle a famous theorem, Pythagoras. So this is your hypotenuse square will be equal to perpendicular square plus base square. And hypotenuse means 13 square is equal to perpendicular. Here it will be 5 plus base your PQ square. So this will be 169 minus 125 is equal to PQ square. So PQ will be square root of 144, and it is your 12 centimeter. In this way, how we did this calculation? By using the properties. Which properties? That the radius is perpendicular to the point of tangent. Okay, point of contact. So by this it becomes the angle 90-degree, and after this we have used the Pythagoras theorem in the right angle triangle and calculated the value as 12 centimeter. Okay, so this is the concept and properties for the tangents. So I hope you understood the topic. If you have any doubt, you can ask me through my Admin Pro profile app. Till then, revise. Let's meet in the next session. Thank you.